Okay, so now we want to look at arc length. Yesterday we looked at the measure of an arc. So arc length and the measure of an arc are two different things. The measure is associated with the angle measure of the central angle that makes it. That's kind of a mouthful there, but we've got our circle and we have a central angle. And then so whatever this is the same as the measure of the arc. So if I call this arc AB, I'm looking for a degree there. I'm looking for a degree measure. When I do length, I'm looking for what's called a linear measurement. And so I want that measurement in inches or centimeters. How long is this thing? This is not something that you would do with a ruler, for instance. In the real world, what you could do is take a piece of string, and I'm going to kind of use my highlighter here as my string, and I would just go kind of lay it there actually right on top of the arc that I wanted to measure, okay, so that the endpoints, I'm marking off the end point of my string from the beginning to the end of the arc, and then I would lift that up and I would straighten it out, and then you could measure that with your ruler and see how long it is. Because the string is flexible, you can do that. Let's say we don't have a string. What is another way that we could do this with a linear measurement? Oh, let's get rid of my little mark there. So when I think about length, I already know a little bit about length of a circle. I know that length in a circle is the circumference. And the circumference is pi times diameter. So I know I can find how long this thing is all the way around. So I have a radius here if I've got an arc. So I know that my diameter is 2 times my radius. And so I could adjust my circumference to be 2r times pi, and that would give me the whole circle. Well, an arc is only a part of the circle. So I want a part of that circumference. And that's where the 360 comes in, and finding out what part or what fraction of the circle is marked off by the arc. So what I want to do to find arc length here, and they're going to call that L is my arc length, is to find the circumference given the radius, and then I want to know what fraction of that is. So I'm going to take the central angle, whatever that measurement is, and in this case it's x degrees, and I'm going to divide that by 360 because that's a whole circle. That's going to give me my fraction. And if I put all that together, I'm going to have the arc length is equal to x degrees over 360, that's the fraction of the circle that's the arc, times my circumference, which is 2 pi r. So I just need to know what a fraction of the circumference is. We're going to try that with example 5. It says find the length of zy. So here's zy. My formula is the length, and then I'm going to find out what fraction of the whole circle is marked off by the arc or the central angle. And then I'm going to multiply that by the circumference to find out what part of the circumference is the arc. And I'm just going to kind of put up here, remember that that's our C for circumference. I actually know all of this already. I've got my x, so my x I need is 75 degrees. That's how much of the circle is taken up by the arc. And I need the radius as well, which is 4 inches. So for my equation, again, it's the length, the arc length, this is L right here, x over 360 times 2 pi r. That's what I'm going to put in there. I've got my x is 75 over 360 degrees times 2 times pi times 4. Now you could simplify that a little bit. This would actually be the same as 8 pi. And so I have 75 over 360 times 8 pi. You're going to put that directly in your calculator. But what you want to do with the fraction is put that in parentheses so that we keep that all together, and then say times 8 and hit the pi button, and then that's going to be what it's equivalent to. Now, if it said to leave it in exact terms, you would leave pi in there. And but we want it rounded, so that value is going to be approximately 5.24 inches. So want to find zy. So same formula. The arc length, so that's my L here, is equal to my fraction. So x degrees, that's just how much, that's really the measure of my arc, over 360 times the circumference, which is, we can say 2 pi r, or we can say pi times diameter. And I'm going to use pi times diameter here just because I have the diameter already. So what do I need to solve this? I need diameter, and I need how many degrees is taken up by the arc. Well, my diameter is 10. If I had used 2 pi r, then I would use a radius of 5 because radius is half the diameter. And then my x degrees taken up by the arc is 130. So 130 degrees over 360 times 10 pi. And that's going to be approximately 11.34 centimeters. Okay, you have the assignment here at the bottom, page 710, numbers 12 through 40, the evens. You should be able to get that done in class, and I will see you on Monday. Have a great weekend.